Hello and welcome to another video brought to you by RouTube. In today's video, we're going to focus on matrix multiplication, which students will be introduced to in Year 11 and then continue developing their knowledge in Year 12 further maths. There's three learning objectives in this video. The first one is to develop an understanding of scalar multiplication. The second one is to decide whether a product matrix exists between two matrices. And the third one, which is to multiply matrices using the run and dive method. The first thing we're going to look at in the video is what we call scalar multiplication. So multiplication of a matrix by a number, whether it be a whole number or a decimal or a fraction, is also known as scalar multiplication. So the number, which we call a scalar, multiplies each element inside the matrix. The order of the matrix is not affected by the scalar multiplication. So the only thing that changes are the values of the elements inside of the matrix. So let's have a look at these two examples here. So evaluate the following if matrix C equals. All right, so here we can hopefully see that we've got a 2 by 3 matrix, which therefore gives us 6 elements inside of that matrix. So evaluate for C. Okay, so essentially what it is asking us to do is our scalar is 4. So then here we've got 4. And then inside our matrix, we've got 23, 12, 8, 11, and 18. So 4 is our scalar. Okay, so like we said before, 4 is going to multiply each element inside the matrix. So each of those 6 numbers inside the matrix. So let's go ahead and do that. Okay, so now you can see I have multiplied, well, I'm about to multiply each of the elements inside the matrix by that scalar number of 4. So now what we can do is, if you need your calculator, don't be afraid to use it. And now we can just work each element out. So 4 times 14 should give us 56. Then 4 times 23 should give us 92. 4 times 12 should give us 48. And then we move to the bottom of the second row. 4 times 8 gives us 32. 4 times 11 is 44, and 4 times 18 is 72. And there we have it. So we have multiplied each of the elements inside the matrix by 4, which is the scalar. So moving over to question number 2, or question B. So now we've got the scalar as a fraction, so it's 1/2. Okay, so essentially you can do two things. You can either divide each element by 2 or multiply it by 1/2. Okay, so there's no difference with which way you do it. So here we're going to set it out just like we did before. So here we've got 1/2, and then we've got 14, 23, 12, 8, 11, and 18. Now once again, we're going to multiply each element inside of the matrix by 1/2 or divide it by 2. It's the same thing. As we can see, I have multiplied each element inside the matrix by the scalar, which is 1/2. And then now we can simply work it out. So the first element in the first row is a 1/2 times 14, which is 7. Then moving across the first row, half of 23 is 11.5, and then we've got half of 12 is 6, and then moving down to the second row, half of 8 is 4, and then half of 11 is 5.5 or 5.5, and then half of 18 is 9. So therefore, you'll see in both answers, the number of elements is not changing. So each time you multiply by a scalar, you're not changing the order, or the order of the matrix is not affected. The only thing that's changing are the values inside of the matrix, so the values of the elements. Okay, now let's move on to deciding whether a product matrix exists between two matrices. So not all matrices can be multiplied together. It's really important to know. Determining whether a product matrix exists between two matrices is dependent on the order of each matrix. Two matrices are able to be multiplied together if the number of columns in the first matrix equals the number of rows in the second matrix. I'm just going to highlight that because that's the most important part about this section. Okay, so the only way that the product matrix can exist, or if you can multiply two matrices, is if the number of columns in the first matrix is equal to the number of rows in the second matrix. And you should be familiar with the order of matrices by now. If you're not, then this might be a little bit difficult for you. Okay, so let's have a look. Decide whether a product matrix exists between the matrices below. So what you need to do is let's have a go at question A. So we have got in our first matrix, hopefully you can identify that this is a 2 by 3 matrix because there are 2 rows and 3 columns. And then the next matrix is a square matrix because there are 3 rows and 3 columns. So they are the order of each matrix. Now, if we go back to what we highlighted in yellow, we need the number of columns in the first matrix to be equal to the number of rows in the second matrix. Okay, so the number of columns in the first matrix is always the second number because the order says that it's rows by columns. And then in the second matrix, that value needs to equal the number of rows in the second matrix. So essentially those two numbers that I underlined, if they are the same, then a product matrix exists and we can multiply those two matrices. And if you do that, whether it's by hand or on a CAS calculator, you should get a resulting product matrix. Now, what we can see is the two numbers that you haven't underlined, okay, which are 2 and 3, which I'll underline in blue. This is actually going to be the order of the product matrix. So essentially that's going to be the order of the answer matrix, okay? But we won't get into that for this video. So we can multiply, or a product matrix does exist between those two matrices. Now moving along to question B, the next one we have here, hopefully you can identify, is a 3 by 4, so 3 rows by 4 columns. And then the next matrix to the right is a 1 by 3. Okay, now once again, number of columns in the first matrix, which is now 4, must match the number of rows in the second matrix. And we can clearly see 4 and 1 are very different numbers, so therefore we cannot multiply those two matrices. Now, if you're working with a CAS calculator and you go and you type those two matrices in and you try and multiply them, you will get something that's called a dimension error. Okay, that is essentially telling you that we cannot multiply these two matrices together because the number of columns in the first matrix does not or is not equal to the number of rows in the second matrix. Okay, now let's have a go at matrix multiplication by hand. So let's determine the product matrix LP if L equals 1, 2, 3, 4. So it's a 2 by 2 matrix, and P equals 6 and 8, which is a 2 by 1 matrix. Okay, so the order in which you're multiplying is extremely important. Okay, so they want us to work out LP. So that means when we multiply, we must have L as the first matrix. Okay, so therefore L is a 2 by 2. So let's just make sure that we can multiply them first. And then P is a 2 by 1. Okay, remember columns, number of columns in the first matrix must match the number of rows in the second matrix. So those values work out. And then the two blue numbers that you underline, that's the order of the answer matrix or the product matrix. Okay, so our answer should be a 2 by 1 matrix, but we'll get to that in a second. Okay, so what we need to do, we are going to use a method which I got from a teacher at my school, which is called the run and dive method. You may have heard of it before. I think it's really, really useful. Okay, so what we do is now we're going to start with the first matrix. So let's just write out our matrices again. So 1, 2, 3, 4, and we're going to multiply 6 and 8. Okay, so what we need to do is we're going to start with the 1, so the first row and the first column. And what we're going to do is as we run across the first row, we're going to dive down the column in the second matrix. Okay, so what it's going to look like is we're going to do 1 times 6, and then we're going to move to the next value or the next element in that row, which is 2, and we are then going to multiply the 2 with the next element moving down or diving down the second matrix. Okay, so it's 1 times 6 plus 2 times 8. And then as we have exhausted the first row, we then start all over again with the second row. So now what we're going to do is, now we run across the first row and then we dive down the column. Okay, so now we start with the first value or the first element in that row, which is now 3. So then it becomes 3 multiplied by 6. And then we add, and then we go to the next value in that row, which is now 4. And then as we're running, we're diving down the second matrix. So it's going to be 4 times 8. Okay, and we can put some of these brackets around, and we'll pop some equal sign as we're going. Okay, so now we can just work it out as we would normally with any values and any operations. So we've got 1 times 6, which is 6, and then 6 plus 16, which should give you 22. And then the second row is 3 times 6, which is 18, and 18 plus 32, so 4 times 8 is 32, so 18 plus 32 gives us 50. And if we have a look at what we started with, the 2 blue numbers that we underlined told us that our answer should be a 2 by 1 matrix. And if we have a look at our answer here that I've just drawn an arrow, that answer is a 2 by 1 matrix. So it doesn't mean your answer is right, it just means that you're sort of on the right track. Okay, so that is how we multiply matrices by hand. Now you can do that on your CAS or Casio just simply by entering in the 2 matrices with a multiplication sign in between. Okay, and you should be all okay to do that. But this is, like I said, if you need to know it by hand or the manual method. All right, and let's finish this video off with another matrix multiplication. So determine the product matrix YZ if Y equals, and then we've got a matrix, and Z equals that matrix there. So once again, the first thing we need to do is determine whether we can multiply these matrices. Okay, so remember the order is extremely important. Okay, so it's Y and then Z, so Y times Z. So let's find the order of each matrix. So the first matrix is we've got 3 rows and 2 columns, and Z, we've got 2 by 3. Okay, so again, those 2 middle numbers need to be the same to multiply, and our answer when we get to it at the end should be a 3 by 3 matrix. Okay, so now I'm just going to write out the matrices as they are. Okay, so I've just written out the questions. Now let's get to running and diving. Now this one's going to be a little bit more complicated just because we've got a fair few more elements or values elements inside each matrix. Okay, but we'll go through it slowly and hopefully you can follow all okay. So let's go as we would per normal. So let's start with the first row. We're going to run across the first row and dive down the first column. Now we're going to go 4 times 2, and then we're going to add and keep running and diving 7 times 3. Now what we do, because we have finished the first row and column, what we need to do now is we need to essentially start again, but we need to keep running. But now what we do is we dive down the second column. Okay, and what we do is we now start a brand new element. Okay, so you'll see there's no addition sign between what we've just done and what we're about to do. So now we're still running down or running across the first row, sorry, but now we're diving down the second column. So now we've got 4 times 4. You see the gap between the 3 and the 4, there's no sign. Okay, so that's a different element. So 4 times 4, and then we're going to add, and then as we're running, we're diving. So add 7 times 9. And then we need to do it again because there is another column. So we're still going to be running across the same row, but now we're just diving down the third column. And then we leave another space between the 9 and then the next value. So now we're going to multiply 4 times 0, and then we're going to add, as we run, we dive. So now it should be add 7 times and then negative 5. Okay, now that we have exhausted the first row, now we can start again and do the same thing, the exact same thing with the second row. So it is fairly time consuming when you have a question like this, but you really need to make sure that you follow the specific process. So now we're going to run. We're now going to run across the across the second row, and then now dive down the first column. So again, we're literally just starting the question all over again, but this time from the second row, not from the first one. So now we should have 5 times 2 plus negative 3 times 3. And then now we are finished with the first column. So now what we can now dive down the second column. So then now we should have, after that, 5 multiplied by 4, and then we're going to add negative 3 times 9. And then now we stay in the same row, but now again, probably getting very repetitive now, going to run down the third column. Sorry, dive down, not run down, dive down the third column. And then now we should have 5 times 0 plus negative 3 times negative 5. And now that we've finished the second row, now again, we start all over again with the third row. So now we're going to run across the third row and then down the first column. So then we should have 9 times 2 plus, and then we're running and diving, 1 times 3. And then now we're done with that column. So then we now move over to the next column and we can dive down that one. Then we've now got 9 times 4, and we're going to add 1 times 9. And then to finish off, we then are finished with that column. And then we can dive down the very last column to then make it 9 times 0 plus 1 times negative 5. And don't forget your brackets at the end. So it's fairly extensive if you get a question like this, but keep running and diving, exhaust each row and run down each column. Dive down each column, sorry, and then you can move on to the next row. Now, what you can do each element by each element, especially with the negatives, just use the CAS calculator or use the Casio, whatever you're using, okay, just to make sure, especially like I said, with the negatives and positive numbers. Feel free to pause and have a go at yourself, but I'm going to just fill out the elements in the answer matrix, which should be a 3 by 3 matrix, which it is. So we've got 29, 79, negative 35, and then we've got 1, negative 7, 15, and then 21, 45, and the final one is negative 5. So there we have our final matrix multiplication question completed manually. And like I said, if you put that straight into your CAS or your Casio, you should get the same answer. Thank you so much once again for watching another RouTube video. Hopefully you learned a thing or two about scalar multiplication and manual multiplication of matrices. and product matrices and everything else that we sort of worked through together. Now I know on your CAS you can do everything that we did by hand, but there are some instances where you might need to use manual methods as well. So as always, please feel free to subscribe, like the video if you learned a thing or two, and as always, I'll see you next video.